You have often described foundations of physics as an orphan in science. So let's define it first. What are the foundations of physics? What is the philosophy of physics? And why do you call it an orphan?
Okay, so the idea of foundations of physics is pretty simple. By foundations, one means what's going on physically at the most fundamental level, where there's nothing sitting below that. So, for example, if you're trying to understand DNA, there's a lot of chemistry, and you can say, look, we figured out that really it has this double helix structure, and this is how these things bind to each other, and that's all very important and gives you a lot of insight. But of course, you can always ask, but how is that double helix made? I mean, how do all the carbons and hydrogens stick together? What keeps them together? And then that pushes you down from chemistry down into physics. And also in physics, there's the physics of, solid state physics. There's all kinds of things you can do in physics about particular states of matter or particular systems, astrophysics or whatever. Yeah. But at the end you say, but at the bottom, that's all the same fundamental physics working its way through some particular situation. You go back to Democritus, and Democritus says that all there is atoms in the void. And, that's not, in a way, not very detailed, but it's very foundational, right? Everything else you're going to understand by saying, well, you've got different shaped atoms and they're moving around in the void, and maybe this one hooks up with that one, or this one bounces off that one. And everything we see at everyday scale is just all that going on at micro scale. That's part of physics. It's not all of physics. There's lots of physics you can do without being terribly concerned about the foundational structure. Yeah. But if you're like me, as I said, and you're just curious and you're just nosy and you just have this, childlike, but why repetition that keeps driving you, it'll drive you eventually down into foundational questions. What is there fundamentally? And this was always thought to be a basic part of physics. The real problem occurred because of quantum mechanics, where there was a very sustained effort to tell people, stop asking these questions, or these questions can't be answered, or they can't be answered in ways you can really understand. Or Bohr was very, very strong on that line of the reason you feel dissatisfied with quantum mechanics is that we've gone beyond the realm where the human mind can really understand. And Einstein was very upset with Bohr because he says, what makes you say that? Why are you giving up? There's no reason to give up. Keep going, right? And you're really being satisfied with things that are quite clearly flimsy and unacceptable as basic postulates. There's a nice letter somewhere where Einstein talks about how quantum mechanics has created this pillow where physicists can sleep, and it's very hard to wake them up. And he says, well, let's just let them sleep, because for decades he was saying there's something ill-defined about this theory, and as a physicist you shouldn't be satisfied with it, not as a philosopher or something like that. And then you say, why is it an orphan? Well, because it should be done in physics departments, and it isn't. And it isn't because of Bohr and because of what happened with quantum mechanics. And all of these questions got sort of sidelined or shunted away or became impolite. And then the people interested in them, some of them drifted off into other places like philosophy departments, where philosophers are happy with questions like that. That's the questions they're most interested in. So it can take some root there, but it's still very scattered. People are just scattered over the world. They're scattered in different departments. There's very little that's institutionally constructed to support these kinds of inquiries.